Welcome back to Lokad TV. This week we're going to be talking about ABC analysis, an inventory categorization method that has its roots in Pareto's 80-20 rule. The method works by splitting a catalogue based on its perceived worth and has been adopted by many major ERP softwares as well as the supply chain industry as a whole. So Johannes, that's a quick overview of ABC analysis, but perhaps you could sort of explain it for us in a little bit more detail?
Yes, I mean, as you pointed out, the ABC analysis takes its root, I would say, in the Pareto analysis, which basically describes entire categories of, I would say, social networks. So basically, it's the idea that when you look anything that is like socially constructed, usually the 20% most active, most important, most something represent 80% of the mass. You will find that on LinkedIn, the total amount of, let's say, connections, the people that have the most connections on LinkedIn, the top 20% is probably having something like 80% of the links. If you look at the wealth, you will have the 20% richest that probably have 80% of the wealth. And if you, in supply chain, if you look at products, the top 20% of products have probably 80% of the sales. And indeed, it's an Italian mathematician and civil engineer, Pareto, who discovered that during the late 19th century. So that's probably the origin, although if we think in terms of categorization of inventory, it probably the idea, just an insight without the math, is probably dating back from the antiquities, but I don't have exactly, I would say, precise sources on that, but I would suspect that people have been doing that like literally forever.
So that's sort of a bit of background to it. So how does it actually work then?
So the key insight in ABC analysis for inventory is to categorize your SKUs or products into classes. You will typically have, let's say, 3 to 5 classes. And you will go from the A class, which is dedicated to the fast movers, to the last class that can be D or E, that is going to be your slow movers, and with classes in between that represent varying, I would say, velocity for your different products or SKUs. So what you do end up is relatively coarse-grained buckets that gather products that have somehow similar inventory velocity. So in terms of how many units do you need to produce or serve on any single day.
Okay, and so is this something that's being used like regularly by companies on sort of a daily basis? Seems like very simplistic, no?
Yes, it is very simplistic. It is widely used in the supply chain world, and I would say widely abused as well. The key insight is that you have some categorization that, so this categorization, how does it help? Well, it helps when you have products that it really reflect the physical constraints that you have on your products. So for example, in aerospace, you would have, say, a first category of products that are very expensive and repairable. So that's going to be your rotable, and you're going to track them at the level of the serial number. Then you're going to have like relatively cheap but still repairable. You're not going to track them at the level of the serial number. You're going to track them, how many units do you have for a different product type. And then you're going to have like consumable, where you just you cannot repair them, so you don't expect that the product will flow back, and you just count the quantity. So that gives you, in this case, different categories, buckets that represent different modalities of handling the goods. In this sort of situation, having classes to reflect, I would say, the distinct physical processes that you have makes sense. Just like, for example, in food industry, instead of aerospace, you would typically have a different processing for frozen food or dry food. Again, those categorization reflect the fact that it's a very different physical handling of the goods. But ABC analysis by itself is not concerned not really about the physical aspects of the goods. It's only concerned about the sales velocity. And when I was reflecting to the abuse, is the idea that you basically create broad categories that are only defined by the relative sales of the products. Because that's, if you have like, let's say 3 classes, A, B, and C, typically what does that mean to be an A item? That means that you have, let's say, above 20 units per day being sold or produced. That will make you an A item. And you see, so that's just a numerical cutoff on the amount of sales that you had for, let's say, the last 3 months. I mean, the recipe vary from one company to the next, but the key idea is that you define a velocity as an average of a certain period of time, and then you define cutoff. One cutoff for each categories that you have, A, B, C, D, E, and this is it.
Okay, well logically it kind of seems to make sense. It kind of sounds like a good idea. You want to categorize your products into which are the most important, which are maybe not so important. I kind of get the impression it's something you don't completely agree with. So why is it not relevant?
So, I mean, the interesting thing is that when you think about the root of this ABC analysis is that it lets you operate over your inventory without doing any counting whatsoever. So if we adopt, I would say, a 19th century perspective on inventory management, what would you do? I mean, for the items of class A, you would take big bins. So you have like large containers, and you would have a rule that is a bit Kanban-like that say, if you see that the bin is half empty, you pass a reorder. And this is it. And then for item B, it's the same thing, but you have a bin that is a bit smaller. And for item C, you probably don't even have a bin, you just have a shelf, and you have one product on the shelf, and when you consume one, you reorder one. Again, a bit kind of Kanban-like. So with these methods, with this sort of organization, you can have a way where you can actually manage your inventory without counting anything. You know, on site, when you go and pick an item, if it's an item A, you could directly look up the bin. If it looks like half empty, you pass an order of, let's say, by default 100 units. If it's an item that match a bin of type B, by default you pass an order of, let's say, 10 units. And if it's item of type C, you pass an order of 1 unit every single time you consume one. So you see that again, that lets you operate your inventory and your supply chain literally without doing any kind of inventory counting, which is great if you do not have any kind of software to run your supply chain. But when we project that in a world where we have computers and we can actually track and count inventory automatically, it doesn't really make much sense, because fundamentally the inventory categorization, the class A, B, C, D, is just like it's a discrete, low resolution approximation of how many units did you produce or consume over the last couple of months. And this is it, which means that any kind of decision that is based on the class could be actually refined more accurately, made more accurate, if instead of using the class, it was actually using the actual sales history of the product instead. And that's where I would say the great fallacy is that the ABC class do not add any additional information to the product compared to just the raw demand history of the product.
So what are the sort of problems that can arise from taking sort of an ABC approach then?
So you have many, I would say overall the main angle is that it's very, very low resolution. It's a bit like you have the capacity to do the calculation by the gram, but you round it up everything by the ton. That's the sort of problem of when you do this. It acts as a massive rounding. So what problems do you have? I mean, first you have problems such as all the products that are within a class can be extremely heterogeneous. It's not because you've created you have, let's say, 2,000 products. It's not because you've created 5 classes that you're very specific. I mean, each class is still containing something like 400 products, and you can have huge amount of heterogeneity in those classes. So that the first problem is that it gives you an illusion that those things are kind of the same, while mostly they are not. And it's true for the top sellers, where typically probably your top 1% of the product is probably having a sales velocity that is like 10 times higher than the top 10%, per product. So that if you have like 5 buckets, you will not get this granularity. Also, at the other end of the spectrum, for the long tail, again, the long tail is very, very long. So it's in the long tail, so your class, let's say you have 3 classes, your class C, it might contain items that are only sold once a month and items that are sold only once every decade. All of that is packed together, and yet it's very, very different the way you want to approach something that is needed once per decade and something that is needed once per month. And then further along, I would say the sort of poems that you get from, I would say, a very crude discrete classification is that this classification tends to be also very unstable over time. We have experimented with several clients, and we were typically noticing that something like between a third and half of the products change of class from one, let's say, period to the next, or one quarter to the next. So basically, when you look at the sales over a quarter, you do your ABC analysis, and you look at the sales data for the next quarter, you redo your ABC analysis. You can end up with a situation where you have, let's say, 40% of the products, and that's really the sort of things that we're observing, that have a different class, which mean that just because you've changed of quarter, suddenly you're going to have like a reorder policy that is completely different for a given item, just because this item changed of class. It doesn't really make sense. If you had an item that had a gradual, but very gradual slowdown over the last 2 years, why would you decide that just because you go from one day to the next, and that you've crossed a certain numerical threshold, that suddenly this item that you were reordering once a month, you would reorder it only twice a year? That gives you tons of very nonlinear effects with lot of gaps. So products that suddenly jump from being reordered once a month to being reordered only once a year, and it's extremely arbitrary, and it does not reflect, the fine-grained evolution of the demand ultimately.
Okay, so how can you sort of approach things in kind of a better way? Because if you're not sort of categorizing your sort of products, how do you sort of know that you're taking care of those products that are really most important to you?
So yes, here it's typically, I would say, a divide and conquer approach that supply chains, that some supply chain manager have over their own supply chain, where they are going to say, in order to make sure that I pay really attention to products that matter the most, I will say, if I have a purchasing manager who is managing items of class A, they are going to manage, let's say, 50 items. And if it's a manager that manages items of class B, this manager is going to manage, let's say, 200 items. And if it's a manager that manages items of class C, this manager is going to manage 1,000 items. So that you have more brain power over the items that are most expensive. However, this is again taking the perspective that all those decisions, supply chain decision, how much do I purchase, how much do I produce, where do I put the inventory, should I actually liquidate the inventory, should I move the price and whatnot, all those decisions are driven by humans who do everything manually. In reality, as soon as you have computers, the whole thing is changed completely. The computer has no problem to basically reprocess thousands of items, dozens of or hundreds or even thousands of times a day, if that's what makes sense. So in order to if you want to ensure that, for example, you have a higher service level for your items A. So what are you really saying? Well, what you're really saying is that if you have an item that is selling more, chances are that you can have a better forecast. Why? Because again, that's the game of number. If you have, it's much easier to forecast if an item is selling as steadily at 100 units a day. You can say next day is going to be somewhere around 100, and that's going to be a reasonably good forecast, maybe plus or minus 10%. If you have an item that is selling once a month, what is the most probable demand for tomorrow is 0 units, but it's very erratic. You might have days where you sell 2, etc. So bottom line, there is a silver lining, which is if you have items that have higher volume, you tend to have lower erraticity, and so ensuring higher service level, so less stockouts, is more cost efficient. Why? Because the amount of inventories that you need to keep is more or less proportional to your lead time on one side and the erraticity on the other side. So if you have basically an erraticity that's twice as large, you need to have twice as much stock. So you need more stock for items that sells more, but comparatively to items that have low sales volume, you need a lot less. So your inventory that you keep for high volume, fast moving items is more efficient in terms of transforming euros or dollars into extra points of service level. So that's why typically you end up with those buckets and all those recipes. But you can seize the problem completely differently. You can say, well, first I'm going to adapt a probabilistic forecast that is going to natively reflect the uncertainty. So for high volume items, I will get a forecast that is high, obviously, but also that is relatively concentrated because my uncertainty is low, and the probabilistic forecast gives you a probability distribution with that reflects the uncertainties that you will have on future demand. And then for, I would say, slow movers, you will get a probability distribution that is going to be where the mean of the distribution is going to be much lower. On average, you have less demand. But the distribution is going to be very spread because there is a lot of uncertainty and a lot of erraticity. And then you combine that with economic drivers. So when you say that you want to have a high service level, what you're actually saying is that for every stock out that you face, you lose margins, and you maybe have, I would say, a stock out penalty, so that you know the karma that you lose with your clients when they expect to find something and that you and you cannot deliver the good that were basically advertised. So the idea is that if you combine the fact that you have economic drivers such as the cost of stock, the carrying cost, the purchasing cost, the cost of stock out, the margin, that is your extra reward because you're going to resell your stuff at something that is beyond your cost, obviously. Then the fill rate is that you get, or the service level that you get, is just the consequence of combining those economic drivers with your probabilistic demand forecast. And the categorization, the ABC categorization, do not even intervene in the calculation because ultimately the ABC categorization is just a crude way either to estimate the future demand or the erraticity of the future demand, which you get out of the box if you have a probabilistic forecasting engine.
So you say it's a very sort of crude way of doing it with ABC analysis. Isn't like a Lokad solution just a much finer grain kind of optimization, kind of an extension of ABC analysis? What's the key difference?
I mean, the key difference is that we would just consider that we have as many classes as we have items and as many classes as we have possible sales history. You see, at some point, if you have a granularity that is so thin that you have one class per situation, the categorization becomes a bit meaningless. And I would say the approach of Lokad is to think of in terms of information, more in the sense of informational theory. Where does the information come from to take a better decision? Ultimately, if all the information originates from the observed sales history, then a forecasting model can potentially internally rebuild its own classification if it helps, you see, but it's inside the forecasting model or engine. And typically, because it's very granular, it's not how it's being done. You know, there is no saving. The only saving of ABC analysis is that it's a sort of methods that let you avoid doing calculation altogether, which is very great if all you have is a pencil and a sheet of paper and thousands of items. Again, I would say supply chain of the 19th century. If you want to track thousands of items by hand, it's a nightmare. And so it was very, very, the clerical cost of keeping track of stuff was very high. So you wanted to have methods where you do not need to do any calculation, not even an addition whatsoever. And it's interesting because those methods were kind of relatively intuitive and ballpark and guesstimate and I would say represent some kind of guesstimation approach. And Lokad, we really take, that's basically the quantitative supply chain approach, is to quantify things to the fullest extent possible, knowing that we have ridiculously fast computers that can do billions of additions a second. So raw processing power is not a scarce resource.
So it's very simplistic, ABC analysis, and you mentioned there one of the real positives is you don't need a pen and paper. And there must be some other benefits to ABC analysis. Why are companies still using it? What are those benefits?
I mean, I'm not sure. Frankly, we have seen a lot of situations. I would say there is a lot of imaginary benefits. Real benefits, tangible benefits, it's much less clear. Again, companies are using that for divide and conquer to basically spread the workload of manually processing the items over many supply chain practitioners. Well, the answer is don't do that. It's a bad idea. You should have something that process uniformly all the items. If you have a method that rely on some kind of bucketization, chances are that you can rethink your method to remove the bucketization and directly use the average demand over the last 3 months. It will typically perform better. You do not need to have something that goes through big increments or big steps. And in terms of reporting, I would say it's an approach where very frequently the management produce tons of vanity metrics, and people are, I would say, entrenched in the habits of say, oh look, dear CEO, we are so good when we look at the A items because our A items have a service level of, let's say, 95%. But again, this is a percentage, not dollars of error. So it doesn't matter if your sales volume, if your A items have a very, very high service level, if your clients, still think that what they really need is the rest. So you see, it's the thing is that you really want to bring it down to, I would say, dollars of performance, dollars of error. I mean, things that are expressed in dollars rather than in percentage. And ABC analysis, it's typically a way to build vanity metrics where you have percentages and you build extra percentages, such as on top of your percentages. And the disconnect with the actual reality can be very, very strong. And if you compound that with the fact that those ABC classes are also very unstable, from one quarter to another, you can end up with the illusion that your metrics are good while actually things are changing all the time. For example, if you have an item that is class A, you suffer a massive stock out. This item is likely to drop into class B very fast just because the amount of units that have been sold dropped because of your stock out. But then, in terms of statistics, it looks good because you just kicked out from your class A an item that was badly performing. So suddenly, the just because you have items where you have massive stock out, they will actually exit themselves from the class A by design, because the class A reflects the sales volume. So if you have a massive stock out on something that is class A, it's not going to last in the class A. It's going to drop very rapidly into class B and C, where you would say, oh, everything is fine again. This product had terrible service level, but it was a class C. So all is well. And no, not all is not well. Here you just have a side effect that things that perform very badly are exiting your fast mover class, but for all the wrong reason.
Okay. Well, I'm afraid we're going to have to wrap things up there. But big takeaway from today is ABC analysis is just for the very vain.
Yes, and don't do that.
Cool. So that's everything for this week. Thanks very much for watching, and we'll see you again next time. Bye for now.